So as Ian mentioned, I'm going to be talking about simulation. In particular, I think that one thing that happens in companies is you learn to do A/B testing, and don't get me wrong, A/B testing is awesome. But I think there's a tendency to think that it's the right tool all the time. And what I'm going to try to talk to you about is how there are alternatives. And for us, we had a situation that wasn't really amenable for A/B testing in real estate in the act of buying and selling houses. And we solved it using simulations. So first, I think I know the answer to this, but can you please raise your hand if you've ever run an A/B test before? Okay, almost all the hands are up. Sorry, can you keep them raised, please? Okay, thank you. Now, follow-on question. Did it go off without a hitch? Okay, most of the hands are down. I still see a couple up. And so, hitch is like, there's an experiment that you tried, and maybe there was a pretty bad user experience. I've experienced this many times. I won't tell you what companies or what experiments, but I think a lot of us can identify with this. For the maybe 2 people who had their hands up, I don't know how much you'll get from this talk. Sounds like you're experts. I think a lot of people have in mind, with the hammer of A/B testing, you imagine you have this picture of beautiful straight nails. But for most of us, I think this is what you end up getting. They're bent in various ways, and you could always do better next time, and you have to try again. So you can imagine a pyramid of causal inference, where as you go down the pyramid, you get increasing confidence in your results, but they come at increasing cost. And you can certainly quibble with this. It's not super precise or anything. But at the top is the observational analysis. So yesterday from Mohammed's talk, if you think of year 1 at Pinterest, you're counting things, right? You're not doing anything really sophisticated. This is the correlation is causation crowd, maybe. I'm claiming that simulation kind of slots in here. So you can be a little bit more confident in the results, but you have to do a little bit more work to get them. Then you can look at quasi-experiments. So you're not actually randomizing anything, but you've got a stream of observational data, and maybe somewhere in that stream you can identify situations that were almost as good as random. So think the econometrics toolkit. And then finally, at the bottom of the pyramid, there's the vaunted A/B test, the gold standard. I would say it's the highest cost, but you can have the highest confidence in your results. That's not to say that it's perfect. A/B testing in networks is really hard, for instance. But I think this is roughly correct. So you've got kind of maybe blindly analyzing data, and then the bent nails. And I'm going to talk about simulations. And you can use simulations to throw out poor candidates for your A/B test. You can use it as a guide in order to have better nails, straight nails. So this talk is going to follow the following structure. I know not everyone, especially in San Francisco, has been through the buying and selling process before, so I have to give a little bit of an overview there. OpenDoor does things pretty differently. We buy houses from sellers, and then it's on us to later find market buyers to resell to. So that's important because the fundamental question that caused us to develop this methodology was around understanding what the risk is we incur when we buy the house from the seller that we have to later resell to a market buyer. And then I'm going to talk about why A/B testing didn't work for us and how simulation saved the day in this particular example. Ian's something to take away for the talk, I hope, is I would like to try to come up with a couple general principles for how simulation may or may not help you. And then the thinly veiled recruiting pitch, or a slide about the company and how we're hiring and everything. So, who am I? I run a support group at work. My name's Nelson. It's been like 2 weeks since my last A/B test. And I've run a lot of these over the years at various companies, Facebook, MetaMarkets, Google. Now I'm A/B testing in real estate at OpenDoor. And I'm going to cover how to, I guess, turbocharge your A/B testing by simulating outcomes instead. OK, so what's OpenDoor about? Moving is a really hard and stressful process, especially around home buying and selling. So we're trying to streamline that process as much as possible. It's a really big industry. So there was a talk about the many terabyte Spark cluster at Facebook. That's a lot of bytes. It's a lot of dollars. Like $25 trillion is the dollar value of all houses in the United States. It touches a lot of people. Almost 2/3 of Americans own their own homes. And it's what people spend the most money on. Every year, you spend an average of $20,000 a year on housing costs. And people buy and sell a lot of houses, $1.4 trillion in aggregate in the United States. And the fees alone are mind-bogglingly large numbers. $100 billion goes to realtors as commission. So the way it works right now, I'm going through the process. Like, has anyone else bought or sold before? OK. So if you see a grimace on my face, then it's like dredging up these bad memories. I apologize. But the way it works right now is if you're looking to sell your house, you decide you want to sell. You find a realtor who's going to shepherd you through the process, be your guide. And you have to invest thousands of dollars in fixing up your house, making it nice for people who are going to walk in. Then you list your house, and then this is when the waiting game begins. If you're lucky, you'll be able to find someone who's interested in buying it quickly. Otherwise, it takes a long time. By the time you get to a serious buyer, and this doesn't happen for everyone, you will have conceded on several points, not least of which is price, also when you close and other contingencies, for instance. And it's not even over yet. People can fall out of contract, and this happens in about 1/7 of cases. And if you're one of the lucky ones who manages to get all the way to closing, it's taken you, I think, 120 days on average in the US. San Francisco is not representative of the rest of the country in this respect. And if you're looking to buy, the process is similarly frustrating. You spend a lot of time doing research. You work with a realtor who's going to help you through the process. But you're the one who's walking into houses trying to find your perfect house. And this is, chances are, going to be the largest financial transaction of your life. And so there's a lot of doubt and uncertainty. What if I buy the house and I have to invest $20,000 or $30,000 in a new roof? What if I don't line up the financing? I have my eyes set on this house. Like I can imagine living my life in it, and the bank won't agree to lend me money. So this side takes 100+ days too, and this affects a lot of people every year, over 5 million Americans. So we decided to rethink this experience, and selling with OpenDoor is pretty easy. You go to our website, you enter your address, fill out a short survey about your house, and we'll give you, within a couple hours, an offer backed by data. And then you just fill out the rest of the contract online. So the key difference is you're selling your house to us, and then now it's up to us to find a market buyer. And the way that works is you start going to our website, you click on one of the cities that we're operating in, filter down to find your dream house, and we have exclusive inventory. And for peace of mind, we give warranty and a 30-day money-back guarantee. So you can refund it for the full purchase price within 30 days. And then you just fill out the rest online. So we're incurring a lot of risk in this process, and we use simulations to try to deeply understand this question of when we acquire a house, how risky is it for us to resell it? So I'm going to present two, I think, motivating examples. There's one home here that looks really nice and fancy. It has some desert landscaping. If you look inside, there's a solarium with a view of the pool, and like a gorgeous pool. There's fountains and other water features, and it's like Mar-a-Lago or something like that. So unsurprisingly, it's at a higher price point. So how long do you think it would take for us to be able to find a market buyer for this house? It's beautiful. Any guesses, like 1 month, 2 months, 3? So, many months? Okay. You're right. Over 6 months on the market. So the higher price point means that there's a smaller buyer pool who can afford it. And maybe it's on a large lot, which is only really possible in the outskirts of town. Again, it's less convenient to get there. Also could depend on the time of year. People don't usually move around the holidays. So this beautiful house took a really long time to sell. And here's a second example. This house looks, it's nice. Nothing wrong with it, but it's just not as fancy as the first one. And it has a backyard, and I'm living in a shoebox here in the city, so like any backyard, even if it doesn't have a pool, is an upgrade. It's a lower price point. So any guesses as to how long this one took to sell? Yes, okay. 1 month. I think that was the time to close, and I think there was an interested buyer immediately. So pretty much what I said about the first house, I think the opposite is true here. Probably in a central location, lower price point, there are many more buyers who could afford it. I don't remember what time of year it was. But with these two examples in mind, this is our risk philosophy. So we bear the risk in trying to later resell the house. And as we saw earlier, the cost can be highly variable. So the cost in number of months for the first house was over 6 months, and then the second house sold very quickly. And we think that it's fair to charge the seller based on their expected cost. So what this means is, if you come with us with a really fancy, custom, high-end house, it'll take us longer to find a market buyer, and we charge a higher fee. Does that make sense? Yes?
Does that mean like you're taking a percentage of the sales price, or what?
Yeah. In this case, it would be a higher percentage. So like, maybe 10 or 11% up from the standard 6%. Yeah. Thank you. So if we wanted to turn this into math a little bit, first, there's a really quick lesson in metrics. The conversion for a seller to accept the offer as a function of the fee that we charge is decreasing. So if we charge a higher fee, then sellers unsurprisingly are less willing to entertain the offer. If you charge a very low fee, then they're happy to partake in the service. However, profit is an increasing function of fee. The higher fee we charge, the more money we make. And these are going to be the two key metrics that we're going to look at for the rest of the talk. They're in tension with one another. Higher fee increases one but decreases the other, and we kind of want both, right? So if you were to write down the math problem that you're trying to solve, it might look something like this. You want to maximize the volume that you do, measured in the number of houses that you acquire, and you want to make sure that you don't lose too much money doing this. Maybe in 1999, the last part was given a little bit less thought. And this maximization problem is going to be over the space of all pricing functions. There's an expression about how writing down the problem gets you halfway to the solution or something. We did not find that to be true in this case. So there are a number of issues with this. The first is that if you think about all the different ways that you could measure risk and charge for houses, even basic parameterizations are infinite dimensional. So how do you know which ones to even consider? You can model various parts of the problem, so you can have a liquidity model and then a pricing model. How do you know how much weight to put on each one? This is the treatment space is very large. And assuming you even whittled it down to one candidate that you thought was pretty good, how do you test this? Well, I can probably ask any of the 90+% of the people who raised their hands earlier. Let's think about what an A/B testing approach would look like. So first, you have to determine your experimental unit, and you can randomize on offers. That is, when an offer comes in, you'll randomly assign either one pricing model or another pricing model. That's pretty straightforward. And then the two metrics that we looked at, conversion rolls up into number of houses, and then we'll profit, you add it, and then you get profit too. So in principle, this seems like it would work, but let me talk about metric measurement lag. The first number, quantity, what this represents is when we make sellers offers, how likely they are to accept our offers. And people usually decide within a couple days, and our offers also expire. So we measure this pretty quickly. It's not like if you're a search engine, you can measure clicks in seconds, but compared with the other number, I'll take days. So then we go on to profit. And how do we measure and book profit? Well, a seller has to accept our offer. That's our revenue. We renovate the house, make repairs, whatever. We list it on the market, and then we have to wait a variable amount of time. And this time is often measured in months. So I think if you were to summarize the situation with one picture, it would look something like this. Exactly how we felt. So two main problems. The first is that A/B testing won't really help you whittle down your candidate space. We are doing a couple hundred houses a month, and depending on the expected effect sizes we're looking at, you really only have enough power to test maybe one or two candidates. So it doesn't help in this situation. And the second is that even if you started your A/B test yesterday, then you're waiting 5 or 6 months, at a minimum before you start getting useful results. So our A/B testing hammer, we have to put it back and then find another tool from the tool shed. There's backpropagation or something, the wrench. Sorry. Okay, so what does our simulation look like? Well, we have historical transaction data, so a stream of people who are expressing interest in selling their houses, they're listing them on the market. And then some of them will have been successful in selling their houses. So they list their houses, and we're trying to simulate what we would have done at a certain point in time. And based on our philosophy, the way we do that is we want to estimate our costs. So we think this house is going to be very costly for us to resell or not very costly. And we hold ourselves accountable to what actually transpired. So if a house ended up taking a really long time to sell and we thought that was going to be the case, then this is good. This idea, if you do machine learning backtesting, it's the exact same thing. And the only real difference is you're doing a backtest for the business. So there's a little bit of business logic in the buying process simulation. In particular, we have to model how a user would react to our offer. But it's the exact same idea. Nothing really new here, I think. So for the two houses we looked at, this is what the process would be. The first house, the very expensive, fancy house, because it took so long to sell, let's say it was $50,000. For us, we finance the majority of our houses, so we have to pay an interest rate every day, and there are also other upkeep costs and property taxes. So you can pretty much translate the time into resale cost. And we're going to compare two different pricing models, one of which consistently underestimates resale costs. So here, it's estimating $10,000. And the two metrics that we care about, seller conversion, or the probability that the seller will accept, is 0.9. It's very high, because the seller is thinking, wow, it's like such an expensive house, it's going to be hard for me to resell. I want to take advantage of this. And unsurprisingly, we lose a lot of money in this case, so $40,000, for instance. And there's another model, our baseline pricing model, which does better. Well, it's more accurate. So it estimates $55,000 in expected resale cost. The seller is less happy in this case, and we book a small profit. So they're only willing to accept with probability 0.1. For the second house, it sold in 1 month, so we can translate it into $10,000, for instance. The pricing model that underestimates costs estimates 5,000, and we lose some money, but you have a happy seller. And in the baseline case, we still lose a little bit of money, and it's less likely that we'll acquire the house. So this is what it looks like for two houses. On our simulation set, it's hundreds or thousands of houses, and the conversion rolls up into an expected number of houses that you acquire, and then the profit just rolls up additively. In this case, the undervaluation one, we would have lost 40 plus 5, so $45,000, and we would have 1.8 houses on average. So what you can do is you can plot the result of the simulation in trade-off space. So you have dollars on the y-axis and volume on the x-axis. And the undervaluation, sorry, the pricing model that consistently underestimates the costs, we end up losing a lot of money there, but we do a lot of volume, making it up on volume. And then the baseline case, relative to that, making some money at the expense of some volume. What you could do is you could start with the baseline, and you could shade the prices up a little bit. So whatever the baseline model says, you add some constant value, for instance. And you could end up with another point in this trade-off space. And then you can shade it down. So you're making less money, but you're doing more volume, and you end up with another point. And you can keep doing this, and you can draw out a curve of business trade-offs. And you repeat the same process with the pricing model that was consistently underestimating the resale costs. So we note that one model dominates the other. That is, for a given quantity, you can make more money. And the way this works is you can imagine if you have a business process where you're optimizing costs, then for the same quantity, it flows directly into margin. In this case, it's the result of a better machine learning model. So the way that you can expand this frontier too is not just based on cost minimization, but you can also, better machine learning models translate into better business outcomes in general. It's not always true. So this is what the simulation gets you. And in the A/B testing world, you only measure these 2 points after 6 months, for instance. And the best you can really do is you can draw a line through them. So you have an immense amount of clarity into the trade-offs. You can tell the CEO, this is where we are operating right now, and depending on the business priorities, we could be here or there. What it lets us do with A/B testing is we can identify that the undervaluation model, it probably had worse machine learning metrics, but in business trade-off space, it's dominated by the existing model, so you eliminate it as a candidate, and you don't even bother with the A/B test in this case. And so you can run as many simulations as you want. You eliminate all the candidates that are dominated, and then you think about the problem again. So we've known how to backtest for a very long time in machine learning. This gets you backtesting with business metrics, which is kind of cool. You're not talking about RMSE or AUC or log loss. You're talking about quantity, volume, and margin and stuff like that. And because you're doing a backtest, it takes seconds versus the forward A/B test, which could take many months for the results to trickle in. So the main cost is computational, but and it's very precise, but how good is the quality of the results? How accurate is it really? And I will return to that in a moment. But I think another really cool thing that the simulation framework gets you is the ability to do a better job planning. So I think one thing that happens in a lot of companies is you have some measure of like, these are the metrics right now, this is where I am, and then you want to set a goal. I want to be X% better in the next quarter or something. And you might do something like this. I've always taken issue with this because it can be kind of demotivating if you don't know if it's even possible or not. Great, like that's the goal. Are we going to be able to meet it? Is it within the realm of feasibility? Who knows? So there's a thing that you can do that's kind of cool with the simulation framework that goes like this. You write down the performance of a perfect model, and the way you do that is, in our house example, this is the actual resale cost we experienced. A perfect model would know that ahead of time, so it would estimate $50,000, and it does. And that admits the two metric measurements, the conversion probability and then profit. We estimated it perfectly, so it's $0. And for the second house, it actually ended up costing $10,000, and you get that perfectly. So this gets you the 0 profit point on that curve, and you can sweep out above and below it by increasing this amount. So from 10,000 to 11,000 to 12,000, and then from 10,000 to 9,000 to 8,000 to sweep out this oracle trade-off curve. Now, this also is a bit unrealistic because all problems have some amount of irreducible error in them. And the measurement of the best performance of the best model in the real world is the Bayes error. So you can come up with this Bayes trade-off curve, which is not the performance of a perfect model, but the performance of the best model given irreducible error. And what you can do now is, again, we have this mapping from machine learning metric space, so RMSE, to business metrics. So you could say, I know what my current RMSE is, and I know, I can guess what the Bayes error is, and now I want to try to bridge that gap by 20%. And you can get something that looks like, it actually looks very similar to the curve that we wrote down before, but I think the way that you got it, the framing is different, and I think that's what matters. So you estimate what you can theoretically achieve, and I think it's a little bit more motivating. It's like within the realm of possibility. You set an improvement in machine learning space, and it translates it directly into, if I'm able to ship this model that's X% better in AUC, then this is the business implication. So I don't mean to downplay the difficulty of actually getting that 20% improvement. The Netflix prize comes to mind. They set an improvement of 10%, and it took 3 years to hit it. I think if they had set it at 20%, then all the fine folks at Netflix who are here would be excitedly talking about, oh, we're at like 11.1 and 11.2% now. I think there's some doubts about whether 20% is actually achievable on that problem, given all the millions of people hours that have been put into the problem so far. So this is just another thing. It might be a little bit more motivating. You can at least have a bound on how well you can ultimately do based on your modeling improvements. And maybe it's the case that the perfect model only yields a very small business improvement, in which case you don't even want to invest in it. So I think it's important for that reason. Okay, so the elephant in the room is how accurate is this approach? We've seen the trade-off curves are extremely precise, but who knows how accurate they are? And I'm going to take a pass maybe at trying to answer this question and say you can use other techniques to get at the accuracy. So where we were with the hammer of A/B testing is you want to do it right, but in practice, something typically goes wrong. This seemed like a really good metaphor. This thing actually exists. It's called a nail assist. So if you use it in concert with a hammer, then you get straight nails. I don't mean to hammer you over the head with metaphor, but I thought it was appropriate. So where we were is you've got this pyramid of causal inference, and with the nail assist, you can supercharge your A/B testing. So the conclusion of the story for us in the real estate example is we ran these many grids of simulations. We came up with a candidate that we were excited about. We were able to offer our service for more people, that is, do more volume to no detriment in profit. And now what, right? What about the accuracy? How much do you really trust those results? So I think it's a very, these decisions should be made on a case-by-case basis, but if we wanted to further vet the results with the gold standard, that is, we have our candidate, we run an A/B test, then we're back to the the second problem we had, which is you still have to wait 6 months, right? We had enough confidence in our results that we decided to do a 100% launch, and then we followed it up with a quasi-experiment, I guess, to try to make sure that the less lagged metric was in line with the simulation predictions. And then as the other metrics roll in, you want to make sure that it doesn't go off the rails. And depending on your situation, the business trade-offs, I think in healthcare, you might want to be a little bit more confident in your results. But it's really up to you, wherever you want to stop. So for us, we didn't quite make it to the A/B test. We stopped at the quasi-experiment, and we were satisfied enough in our results. But I think it's really situational. So how can we apply this more generally? In our case, we had historical transaction data, so houses that listed and sold. We had a user model. And the way that we tried to estimate the prices we would have offered is based on our costs. And then we held ourselves accountable to the actual outcome, what actually transpired for the house. I think the two main ingredients, one is the data part. You don't strictly need historical data. I think you just really need a data generating process. And I think the second key ingredient in this framework is, for us, we simulated our buying process, but more generally, you want a user model. So for the first part, how do you think about the data generating process? Everyone logs data. There's a talk after this about logging that I'm really excited about. So the way we replayed our historical data in real estate was we had a list of houses that listed and sold. So we used past housing transactions. If you're Lyft or Uber, then you surely have logs of passengers who are opening up their phones trying to request rides. If you're Google or Bing, you similarly have people searching, you have search sessions. So what terms are people searching for, how do they navigate, and so on. And you also have the stock of potential ads that could have shown but possibly did not show, but might under a given perturbation of the auction if you had boosted the bid, for instance. So simple version, I think, is people have logs. You can just iterate over the logs. That's pretty good. And for the user model, in real estate, for us, we were trying to model the probability that a seller would sell their house to us given the fee that we charge. And this was the downward sloping. People don't want to pay more money, obviously. If you're a ride-sharing service, then maybe the relevant user model is the probability that a rider is going to accept the ride given the price that you're offering and also how far away the driver is. And if you're a search engine auction, then you get paid by the click, and you care a lot about modeling the probability that a user will click on an ad, given everything you know about the user and everything you know about the ad. So, I wanted to say that this is not a silver bullet, and I think another key assumption is that what you're trying to simulate is modeled in the user model. For instance, Uber recently launched a new UI, and that is not amenable to this kind of simulation because, well, if they're modeling the probability that you'll accept a ride given the price in the ETA and not UI, then it's blind. It has no power to detect anything, right? You'll say, hey, I'm going to simulate the new UI launch, but the user model doesn't take that into account, so you see no difference. So, yeah, wanted to make that clear. In closing, I think if you remember one thing, it's to please A/B test responsibly. And just consider simulating before testing. So just a little bit about the team and the problems we're working on. At OpenDoor, we were founded almost 3 years, actually, just over 3 years ago. We're buying and selling a couple hundred houses a month, and we have a couple hundred employees, 50 data scientists and engineers, and we're working on causal inference problems like this, trying to better model the price of houses, ingest as much real estate data as possible if it can help us better understand the risks associated in buying and selling houses or understanding our valuation of houses. And we are hiring. If you want to talk about anything, my email address is nelson@opendoor.com. I'm also going to hold office hours right after this talk, I think upstairs. And many people contributed, my awesome colleagues, to this talk. So thanks to them. And I think I have, well, maybe not time for questions because we're a little bit late, but I'll leave it up to Ian. Thank you.
Cool, thank you, Nelson. I think we can take one question. Or, okay, two.
Oh, sorry. If you have ideas about how to use this in other use cases or have done it before, I would love to talk to you about it because I find this stuff super interesting.
So during your talk, there were two things that kind of came to mind that make me wonder about your testing strategy. One is it's backward looking, and what happens as the dynamics of the economy change.
Yep.
And then the other one is, are there any kind of concerns, like sort of regulatory concerns around, your models potentially discriminating against people based on geography or things that might be proxies for, protected groups?
Oh, so you're absolutely right in the first point. I think John was just saying about the standard disclaimer with all the stuff is that the past performance is not reflective of a future. For the regulatory stuff, I know if you're doing regulated work, like I think in financing, I don't touch that, but we have lawyers, and I think we're very sensitive to those concerns, but I don't know anything more.
So I'm curious, have you run into cold start issues where when you enter a new market, you just don't have data to do simulations?
Yeah, we definitely do. So we rely on other data sources that aren't our own where we don't have any operational history. Yeah, that's a big problem for us.